Hello, I'm Robert Miles. Welcome to this recording of the Alignment Newsletter podcast. This is newsletter number 168, 4 technical topics for which OpenPhil is soliciting grant proposals, published on the 28th of October 2021 by Rohin. Highlights. Link, request for proposals for projects in AI alignment that work with deep learning systems, by Beckstead and Asya Bergal, summarized by Rohin. Open Philanthropy is seeking proposals for AI safety work in 4 major areas related to deep learning, each of which I summarize below. Proposals are due January 10th and can seek up to $1 million covering up to 2 years. Grantees may later be invited to apply for larger and longer grants. Rohin's opinion. Overall, I like these 4 directions and I'm excited to see what comes out of them. I'll comment on specific directions below. Link RFP, Measuring and Forecasting Risks, by Jacob Steinhardt, summarized by Rohin. Measurement and forecasting is useful for 2 reasons. First, it gives us empirical data that can improve our understanding and spur progress. Second, it can allow us to quantitatively compare the safety performance of different systems, which could enable the creation of safety standards. So, what makes for a good measurement? 1. Relevance to AI alignment. The measurement exhibits a failure mode that becomes worse as models become larger, or tracks a potential capability that may emerge with further scale, which in turn could enable deception, hacking, resource acquisition, etc. 2. Forward-looking. The measurement helps us understand future issues, not just those that exist today. Isolated examples of a phenomenon are good if we have nothing else, but we much prefer to have a systematic understanding of when a phenomenon occurs and how it tends to quantitatively increase or decrease with various factors. See, for example, scaling laws from Newsletter 87. 3. Rich data source. Not all trends in MNIST generalize to CFAR10, and not all trends in CFAR10 generalize to ImageNet. Measurements on data sources with rich factors of variation are more likely to give general insights. 4. Soundness and quality. This is a general category for things like, do we know that the signal isn't overwhelmed by the noise, and are there any reasons that the measurement might produce false positives or false negatives? What sorts of things might you measure? 1. As you scale up task complexity, how much do you need to scale up human-labeled data to continue to maintain good performance and avoid reward hacking? If you fail at this and there are imperfections in the reward, how bad does this become? 2. What changes do we observe based on changes in the quality of the human feedback? For example, getting feedback from amateurs versus experts. This could give us information about the acceptable difference in intelligence between a model and its supervisor. 3. What happens when models are pushed out of distribution along a factor of variation that was not varied in the pre-training data? And 4. To what extent do models provide wrong or undesired outputs in contexts where they're capable of providing the right answer? Rohin's opinion. Measurements generally seem great. One story for impact is that we have a measurement that we think is strongly correlated with X risk, and we use that measurement to select an AI system that scores low on such a metric. This seems distinctly good, and I think would in fact reduce X risk. But I want to clarify that I don't think it would convince me that the system was safe with high confidence. The conceptual arguments against high confidence in safety seem quite strong and not easily overcome by such measurements. I'm thinking of objective robustness failures, see Newsletter 66, of the form, the model is trying to pursue a simple proxy, but behaves well on the training distribution until it can execute a treacherous turn. You can also tell stories where the measurements reveal empirical facts that then help us have high confidence in safety by allowing us to build better theories and arguments, which can rule out the conceptual arguments above. Separately, these measurements are also useful as a form of legible evidence about risk to others who are more skeptical of conceptual arguments. Link RFP, Techniques for Enhancing Human Feedback, by Ajay Kotra, summarized by Rohin. Consider a topic previously analyzed in Aligning Narrowly Superhuman Models, from Newsletter 141. How can we use human feedback to train models to do what we want, in cases where the models are more knowledgeable than the humans providing the feedback? A variety of techniques have been proposed to solve this problem, including iterated amplification from Newsletter 40, debate from Newsletter 5, recursive reward modeling from Newsletter 34, market making from Newsletter 108, and generalizing from short deliberations to long deliberations. This RFP solicits proposals that aim to test these or other mechanisms on existing systems. there are a variety of ways to set up the experiments so that the models are more knowledgeable than the humans providing the feedback. For example, 1. Train a language model to accurately explain things about a field that the feedback providers are not familiar with. 2. Train an RL agent to act well in an environment where the RL agent can observe more information than the feedback providers can. And 3. Train a multilingual model to translate between English and a foreign language that the feedback providers do not know. Link RFP Interpretability by Chris Olah, summarized by Rohin. The author provides this one-sentence summary. We would like to see research building towards the ability to reverse engineer trained neural networks into human-understandable algorithms, enabling auditors to catch unanticipated safety problems in these models. This RFP is primarily focused on an aspirational intermediate goal to fully reverse engineer some modern neural network, such as an ImageNet classifier. Despite the ambition, it's only an intermediate goal because what we would eventually need is a general method for cheaply reverse engineering any neural network. The proposed areas of research are primarily inspired by the circuits line of work from Newsletter 142. 1. Discovering features and circuits. This is the most obvious approach to the aspirational goal. We simply turn the crank using existing tools to study new features and circuits, and this fairly often results in an interesting result that makes progress towards reverse engineering a neural network. 2. Scaling circuits to larger models. So far, the largest example of reverse engineering is curve circuits with 50,000 parameters. Can we find examples of structure in the neural networks that allow us to drastically reduce the amount of effort required per parameter? As examples, see equivariance and branch specialization. And 3. Resolving polysemanticity. One of the core building blocks of the circuits approach is to identify a neuron with a concept so that connections between neurons can be analyzed as connections between concepts. Unfortunately, some neurons are polysemantic, that is, they encode multiple different concepts. This greatly complicates analysis of the connections and circuits between these neurons. How can we deal with this potential obstacle? Rohin's opinion. The full RFP has many more points about these topics. It's 8 pages of remarkably information-dense yet readable prose. If you're at all interested in mechanistic interpretability, I recommend reading it in full. This RFP also has the benefit of having the most obvious pathway to impact. If we understand what algorithm neural networks are running, there's a much better chance that we can catch any problems that arise, especially ones in which the neural network is deliberately optimizing against us. It's one of the few areas where nearly everyone agrees that further progress is especially valuable. Link RFP Truthful and Honest AI by Owain Evans, summarized by Rohin. This RFP outlines research projects on truthful AI, summarized below. They fall under 3 main categories. 1. Increasing clarity about truthfulness and honesty. While there are some tentative definitions of these concepts, there's still more precision to be had. For example, how do we deal with statements with ambiguous meanings, or ones involving figurative language? What's the appropriate standard for robustly truthful AI? It seems too strong to require the AI system to never generate a false statement. For example, it might misunderstand the meaning of a newly coined piece of jargon. 2. Creating benchmarks and tasks for truthful AI, such as Truthful QA from Newsletter 165, which checks for imitative falsehoods. This is not just meant to create a metric to improve on. It may also simply perform as a measurement. For example, we could experimentally evaluate whether honesty generalizes, see Newsletter 158, or explore how much truthfulness is reduced when adding in a task-specific objective. And 3. Improving the truthfulness of models, for example by fine-tuning models on curated datasets of truthful utterances, fine-tuning on human feedback, using debate from Newsletter 5, etc. Besides the social benefits from truthful AI, building truthful AI systems can also help with AI alignment. 1. A truthful AI system can be used to supervise its own actions by asking it whether its selected action was good. 2. A robustly truthful AI system could continue to do this after deployment, allowing for ongoing monitoring of the AI system. And 3. Similarly, we could have a robustly truthful AI system supervise its own actions in hypothetical scenarios to make it more robustly aligned. Rohin's opinion. While I agree that making AI systems truthful would then enable many alignment strategies, I'm actually more interested in the methods by which we make AI systems truthful. Many of the ideas suggested in the RFP are ones that would apply for alignment more generally, and aren't particularly specific to truthful AI. So it seems like whatever techniques we use to build truthful AI could then be repurposed for alignment. In other words, I expect that the benefit to AI alignment of working on truthful AI is that it serves as a good test case for methods that aim to impose constraints upon an AI system. In this sense, it's a more challenging, larger version of the never describe someone getting injured challenge from newsletter 166. Note that I'm only talking about how this helps AI alignment. There are also beneficial effects on society from pursuing truthful AI that I haven't talked about here. Section AI Governance. Link Truthful AI, Developing and Governing AI That Does Not Lie, by Owain Evans, Owen Cotton Barrett et al., summarized by Rohin. This paper argues that we should develop both the technical capabilities and the governance mechanisms necessary to ensure that AI systems are truthful. We will primarily think about conversational AI systems here, so not, say, AlphaFold. Some key terms. 1. An AI system is honest if it only makes statements that it actually believes. This requires you to have some way of ascribing beliefs to the system. In contrast, truthfulness only checks if statements correspond to reality, without making any claims about the AI system's beliefs. 2. An AI system is broadly truthful if it doesn't lie, volunteers all the relevant information it knows, is well calibrated and knows the limits of its information, etc. 3. An AI system is narrowly truthful if it avoids making negligent, suspected falsehoods. These are statements that can feasibly be determined by the AI system to be unacceptably likely to be false. Importantly, a narrowly truthful AI is not required to make contentful statements. It can express uncertainty or refuse to answer. This paper argues for narrow truthfulness as the appropriate standard. Broad truthfulness is not very precisely defined, making it challenging to coordinate on. Honesty does not give us the guarantees we want. In settings in which it's advantageous to say false things, AI systems might end up being honest but deluded. They would honestly report their beliefs, but those beliefs might be false. Narrow truthfulness is a much stronger standard than we impose upon humans. This is desirable because, 1. AI systems need not be constrained by social norms the way humans are, consequently they need stronger standards. And 2. It may be less costly to enforce that AI systems are narrowly truthful than to enforce that humans are narrowly truthful, so a higher standard is more feasible. Evaluating the narrow truthfulness of a model is non-trivial. There are 2 parts. First, determining whether a given statement is unacceptably likely to be false, and second, determining whether the model was negligent in uttering such a statement. The former could be done by having human processes that study a wide range of information and determine whether a given statement is unacceptably likely to be false. In addition to all of the usual concerns about the challenges of evaluating a model that might know more than you, there's also the challenge that it's not clear exactly what counts as unacceptably likely to be false. For example, if a model utters a false statement but expresses low confidence, how should that be rated? The second part, determining negligence, needs to account for the fact that the AI system might not have had all the necessary information, or that it might not have been capable enough to come to the correct conclusion. One way of handling this is to compare the AI system to other AI systems built in a similar fashion. How might narrow truthfulness be useful? One nice thing it enables is truthfulness amplification, in which we can amplify properties of a model by asking a web of related questions and combining the answers appropriately. For example, if we're concerned that the AI system is deceiving us on just this question, we could ask it whether it's deceiving us, or whether an investigation into its statement would conclude that it was deceptive. As another example, if we're worried that the AI system is making a mistake on some question where its statement isn't obviously false, we can ask it about its evidence for its position and how strong the evidence is, where false statements are more likely to be negligently false. Section 3 is devoted to the potential benefits and costs if we successfully ensure that AI systems are narrowly truthful, with the conclusion that the costs are small relative to the benefits and can be partially mitigated. Section 6 discusses other potential benefits and costs if we attempt to create truthfulness standards to ensure the AI systems are narrowly truthful. For example, we might try to create a truthfulness standard, but instead create an institution that makes sure that AI systems follow a particular agenda, by only rating as true the statements that are consistent with that agenda. Section 4 talks about the governance mechanisms we might use to implement a truthfulness standard. Section 5 describes potential approaches for building truthful AI systems. As I mentioned in the highlighted post, these techniques are general alignment techniques that have been specialized for truthful AI. Section News. Link, Q&A panel on applying for grad school, summarized by Rohin. In this event, run by AI Safety Support on November 7th, current PhD students will share their experiences navigating the application process and AI safety research in academia. You can RSVP at the link evt.to/DHAIMISW. Link, Safe AI Workshop 2022, summarized by Rohin. The Safe AI Workshop at AAAI is now accepting paper submissions, with a deadline of November 12th. Link, FLI's $25 million grants program for existential risk reduction, summarized by Rohin. This podcast talks about FLI's recent grants program for X-risk reduction. I've previously mentioned in Newsletter 165 the fellowships they're running as part of this program. As a reminder, the application deadline is October 29th for the PhD fellowships and November 5th for the postdoc fellowship. This concludes Alignment Newsletter number 168. For more information, you can go to rohinshah.com/alignment-newsletter, where you can find all of the previous newsletters and also a spreadsheet of all of the papers and summaries that have ever been featured. Thank you for listening.